Welcome to this Think Small Cell webinar entitled Multi-Operator Solutions for In-Building Wireless. I'm joined today by Randall Schwarz, Principal Analyst at Wireless 2020, and Nick Johnson from small cell vendor ip.access. And between them, we'll be looking at the various technical and business attributes of how you provide good cellular in-building service that supports multiple network operators. So the structure today is that we're going to ask Randall to talk us through an overview of today's in-building cellular solutions, look at the different building size and specifically this concept of middle prize buildings, and talk about some of the trends around the solutions for in-building networks. And after an audience poll question, we'll move across to Nick Johnson of ip.access. We'll be looking at the various architectures that support multiple operator small cell solutions and how that can be deployed on a neutral host basis. We'll also talk through some of the business model issues and specifically look at specific examples comparing the costs of different solutions for different sizes of buildings. And as I said earlier, we'll wrap up with a Q&A session. So without further ado, let me hand over to Randall Schwarz to talk through an overview of today's in-building solutions. Over to you, Randall.
So good morning to everyone who's on the phone. This is Randall Schwarz from Wireless 2020. I think many of you may know, but just by way of short introduction, Wireless 2020 is a broadband wireless consulting group. We work with operators around the world to help them develop their technology strategy and their market strategy. And as we look at key trends in the industry, we look at in-building wireless as one of the key areas, and there are several drivers around this. But as the capacity demands and the demand for near perfect coverage at all times, no matter where you are, since 80% of the traffic is generated indoors, very excellent coverage for all users in building becomes actually absolutely one of the critical areas as operators look to continue to expand and improve their networks. So when we look at a snapshot of technologies today and we look at the solutions that are available, we look at distributed antenna systems, DAS, and these have been very successful, particularly targeted at larger venues such as stadiums and airports and large malls and even large office buildings. So that has a great capability to be able to offer multi-operator capability, and particularly in those large venues, since we would expect to see a user population from across the spectrum of whatever country you're in. There are probably users from all operators who might be in a venue such as that. The next that we typically look at is single operator small cells, and this today is one of the limitations of small cells. While they're quite excellent in providing targeted coverage and capacity, for the most part, they're mostly targeted for a single operator. So if you have a building, perhaps where an enterprise building where the company that resides there has a contract with one particular operator, it might be very helpful to have small cells from that operator to help improve coverage in the building. But if we want to have coverage for multiple operators with that sort of technology, we really would need to put in 3x or 4x the amount of infrastructure into the building to provide coverage for all of the operators. The third, and this is kind of one of the emerging areas that we're highlighting this morning, is if you have multi-operator small cells. And to take away that limitation of small cells being targeted for one operator, if a set of small cells, one infrastructure that can support all of the operators, then that provides some real both technology, implementation, and economic benefits. So we'll go to the next slide. We talked DAS in particular being targeted at the largest venues. And what we've seen in the market is that the largest venues have gotten a lot of support and have gotten a lot of implementation for things like airports, large enterprise buildings, stadiums, large shopping malls. Let's say something over 500,000 square feet or so, and DAS is quite applicable to that. What we've seen is rather a big hole in the market is what we're referring to here as middle price, and you may or may not have heard that term. It's been used in the industry a fair bit. And when you look at these medium and small size venues, whether it's smaller apartment buildings, maybe business parks, hospitals, hotels, the expense of DAS becomes difficult, and really there's kind of a hole in the solution space for being able to support these middle-priced kinds of venues. And we'll go to the next slide. One of the things that's important to note here, while these tier 1 venues are very high value and have lots of subscribers and can deliver lots of traffic, for the operators if we can provide support there. There are kind of, let's say, tens of thousands of tier 1 venues, but as we look at tier 2 venues, there are hundreds of thousands, and as we get to tier 3, maybe 4 or 5x the number even of the tier 2. So while each of those venues may be small and of themselves, they're largely unsupported. That's certainly where the biggest hole is in the market, and there are many, many more of these venues. And so someone that would like to either create a solution or develop as perhaps a neutral host provider or some kind of service provider that would like to provide service to those venues, there's a great opportunity, and we've seen this opportunity quoted as a $20 billion opportunity when we look at this around the world. So it's a fairly significant space if we can find the right kind of solution. And so as we look around the world, these trends are as applicable in the medium and small venues as they are in the larger venues. So the expansion of the use of BYOD, that's bring your own device usage in the enterprise environment, typically means that multi-operator mobile service is now mission critical for many of the enterprise residents of these buildings. Changes in in-building building construction standards, LEED standards, in many cases, one of the artifacts of that is it prevents or it makes it far more difficult for outdoor coverage from a macro cell near that building to penetrate indoors. This emphasizes the need to have an in-building network. I mentioned this before, but about 80% of the traffic is generated indoors, perhaps in the wintertime, even more than that. So this, again, the need to be able to have excellent coverage indoors becomes a mission-critical issue. And the quality of wireless service has become the norm. In many cases, if a company is shopping for office space, for example, it's probably in the 4 or 5 bullets of requirements that they'll give to their real estate company to say, we must have 5 bars of coverage inside of that building. And the other trend that's really interesting is that venue owners are realizing the value of importance of having excellent wireless service in their building. And so this in some ways leads to uncertainty in the business model, and that could be one of the lead impediments really to implementing an excellent solution. So as we look at this, and when we apply these to medium and small venues, there's a challenge for these venues. They have the need to have multi-operator support, but it's difficult maybe to support the high overhead cost of DAS. So small cells should look like a good solution for these venues, but a typical small cell solution can have a lower cost, but if you need to support 4 operators in a building, typically you would need to support a 4x infrastructure to support all of them, and so you may save on CapEx, but in some cases perhaps even the OpEx might be higher in those sort of implementations. So a multi-operator small cell solution could offer us the best of both worlds. There are some challenges that need to be met when you deploy an in-building network for multiple operators. Either you have to support all of the spectrum for that each of the operators need, or the operators can agree to have one neutral spectrum that they could support, which could be a donor spectrum from one of the MNOs that the other operators agree to use, and in some markets this may be quite viable. Coming in the future, and many have possibly heard of that, a neutral spectrum like CBRS or multi-fire, if you can support those single spectrum usage, that's another way that you could have a multi-operator small cell solution. But then you add to that, you need to support all of the traffic demands of the operators, have a virtual EPC so that you can handle the traffic and send the traffic to all of the MNOs to support their all of their business requirements. And then the last is develop a business model. And again, this is the area where Wireless 2020 specializes in, and really understanding the ins and outs of, to deploy these technologies, who pays who, who pays for the service, who owns the infrastructure, who winds up paying the CapEx and the OpEx for the infrastructure. Those issues become critical. So really quite a challenge, but if that challenge can be solved, as we pointed out before, really a tremendous business opportunity to be able to support these kinds of services in medium and small size buildings, what we call the middle prize. Thank you very much.
Thanks very much, Randall. I think that was a very succinct tour around the market status of the middle prize, and I should point out to our viewers that this comes from a white paper that Wireless 2020 published in conjunction with ip.access, and we'll provide a link to the full white paper at the end of the session. The next step in this webinar is that we'd like to encourage some audience participation. So what we're going to be asking is whether any of the following applies to you in the building, and I'll just pop up the voting form in front of you now. So what we're asking is, regardless of who you work for or where you are, what type of in-building system is installed, if there is any, where you're working today. And ideally, we'd like you to tick one or possibly more of the first 3 boxes to see if you have a DAS system or a small cell in your building, and secondly, one of the last 2 boxes to indicate whether you have good or poor service. So you may well not have any in-building system, and you may have a perfectly good indoor service, or conversely, you might have an in-building system that's not working very well for you. So please do vote now. Randall, can you see the results on your screen?
I can.
Any thoughts or comment about that?
Well, I think that's rather in line with I think about what I would expect. I see between poor indoor service and good indoor service, we've got kind of 32%, 32%. But maybe the rest aren't sure, but it's interesting that about half of the buildings are covered, and 59% have nothing. So that seems to indicate there are some perhaps frustrated users who would love to have some kind of in-building system to improve coverage in their building.
Indeed, there's room for improvement, and dare I say, perhaps some of our audience is slightly skewed because they might be small cell enthusiasts and so have a few more than perhaps our the norm for the population as a whole. All right, well, that's an interesting feedback. We have a second poll question now, and that's really asking when we think the audience believes middle prize will become widely deployed. Is this something that will grow very quickly in the next 1 or 2 years? Is it more 3 to 5 years or longer? Or perhaps it'll never happen. Most people think it's going to happen at least within the next 5 years, and only 1% thinks it will never happen. So that's a pretty optimistic view, I think. Randall, do you have any comment about the time frame shown here?
I think that's right on with our speculation. I'm kind of important to see that kind of response. I think that the operators are really, I think this applies universally around the world, are quite challenged, and in a flat revenue per subscriber scenario in competitive markets, they still have the challenge of ever increasing their capex to keep expanding capacity and coverage. So it's difficult for them to come to every building, but I think that what this says to me is this is a very real issue that over the next 5 years or so, almost every building will probably receive some kind of treatment to improve coverage if the technology is there and if the business models are there.
Yeah, I would say I'm also heartened by this poll. Nick, do you have any comments?
No, equally encouraged. I think that sort of split between a 1 to 2 year frame and a 3 to 5 year frame maybe is interesting. I think I think we're all looking for, there are clearly some obstacles to clear away before it can get widely deployed, and I think that's probably a reasonable future cast, I think.
A future cast indeed. Okay, I will now go back to the presentation and pass on to Nick for your presentation about the solutions for the future. Over to you, Nick.
Thanks, David. So next few slides then, really talking about the kinds of solutions that people are deploying in small cells now. I think there is a general trend towards not just from large enterprise towards the middle price, but also a trend away from DAS and towards small cells. I think even when you're not worried about multi-operator, and I think the kinds of solutions that are coming out there, I think, are now becoming more and more deployable. I think people have been concerned about the complexity of small cells and the deployability of small cells. I think those issues are generally solved now, and I think people are deploying small cells with a high degree of confidence. And I guess we saw in that first poll that 19% of the respondents said they had a small cell solution in their buildings, which was quite encouraging as well. I think right on trend. And the kind of small cell deployments, I think we're seeing a lot of deployments today in this model, the kind of model that's on the screen at the moment, where essentially each operator deploys, or each operator is still responsible for their own coverage and their own spectrum. So there's a deployment of multiple small cells, one for each operator, and each one has their own gateway back into the core network. I think there are at least 2 companies, and there are bound to be more that we're aware of. There's OpenCell in the UK, and there's Clear Sky in the US, who are deploying in this kind of model. Various levels of added value that each of them bring to that. I think operators are still very keen to maintain operational management control over the radio devices in their network, and nevertheless, the neutral host that is deploying these multiple small cells, still bring a lot of value in terms of installation and first-tier support. They can actually rectify a lot of the issues in terms of deployment and the immediate availability that without having to worry the operator. So even in that model, there's quite a good cost saving there for the mobile operators, which lets them get into buildings that they wouldn't otherwise reach. That trend really continuing in our view to include, so if you actually share all of the infrastructure, not just the installation, but share the active ingredients, share the active elements, share the gateway, share the backhaul, then you get to a model that looks a bit more like the next slide, where you've got a whole range. You can actually then carry all of the traffic through one device, obviously sharing the deployment cost amongst all of the operators now, and not just expecting every operator to deploy their own infrastructure. So there's an immediate cost saving that's obvious there, both in CapEx and OpEx. So the cost of deployment, the physical space you require to deployment, the operational cost in terms of the power to run these things, the cost of the backhaul, and so on. Each of these things is very much shared between the operators. One of the things that goes with this model, though, is of course that the operators themselves give up a little bit of operational responsibility for that, and so that cost is also shared between the operators and that decreases the cost of ownership then for this kind of solution even further. And it's a step that is being taken in many parts of the world already. And of course we have that is being paralleled, being tracked by new spectrum licensing arrangements. So Randall mentioned in his section the emergence of CBRS in the US and multifier in 5 GHz spectrum, which of course then will become a global standard, which allows infrastructure to be shared all the way to the spectrum and deployed in that basis. I think the CBRS, I think, is a model that is destined for global reach, I think, because it is based in 3.5 gig spectrum, which is essentially the old WiMAX spectrum, and has been identified by as essentially a global 5G band going forward. So I think we're going to see more spectrum sharing arrangements baked into the regulations as we go forward around the world. So I think what CBRS is pioneering in the US, I think is going to become the de facto standard for the way spectrum is shared amongst users as we go forward into the century. And if we click on to the next slide, we'll see essentially the white paper captures really the impact of this model on all of these players, on all of the mobile operators, the DAS vendors, the small cell vendors, and the building owner, their tenants, and also the Wi-Fi vendors as well. So I think we're seeing that actually Wi-Fi sitting alongside this. Wi-Fi, of course, is, if you like, the standard way of doing shared infrastructure today, since it's not really aligned with any operator, essentially provided by the venue as the default neutral host model. But I think we're going to see that change certainly as the Wi-Fi networks of today find themselves congested and hard to access, especially in busy places. Then we're going to see neutral host cellular service become one of the most valuable and most used models going forward. So the model really is looking at the way the neutral host, the way the money flows between all of these players through the neutral host, and the basic model is that the enterprise pays. I think that's the enterprise is willing to pay all of the evidence is that the enterprise is really extraordinarily demanding, there's an enormous amount of pent-up demand for cellular service, for shared operator cellular service. The most obvious reason for that is that it increases the value of their property, and that allows them to increase their the occupancy. Tenants are easier to come by and easier to retain if the cellular service in those buildings is better, and that translates into higher value in that building. So the actual income from that building is better. But let's see what the numbers say. I mean, it's all right to assert that, but let's see what the numbers say. If we go and look at the first one here, isn't really even in the middle price. You would say it's actually a smaller. It's only 8,500 square feet. It's not a big enough place to merit its own macro cell, but it may be on the edge of coverage, and each of the within the buildings, and for all the reasons that Randall mentioned in terms of construction standards and so on, actually the coverage inside those buildings very difficult to guarantee. The tenants in these complexes may be very large chains, that of which there may be many thousands or tens of thousands in a country. So it's small, but it's very important. And you can see here that in terms of numbers, actually, these are obviously for DAS. This is a theoretical number. No one would spend $100,000 deploying DAS in such a place. But when you do share the infrastructure, and the way even if you're doing it with single cells, you get a good cost saving. But if you're able to share those small cells then between the operators, then you really get to the a price point, a TCO that justifies that into even the smallest venue. So if we go up an order of magnitude in size, looking here at an enterprise building of 70,000 square feet, quite a few more subscribers there. But a medium-sized building, rather modelled on our own enterprise. So it's again a rather similar scaling, if you like, between there. It's a little bit more expensive all around. The DAS is more expensive. The single operator small cell is more expensive, and the single small cell then is again wins out if you're able to share it. I think you can see here there's not always although this is assumed shared between 4 operators, it's not an exact 4-to-1 ratio between the small cells without Sumo and the small cells in the shared model. So not all of the CapEx and OpEx multiplies by the number of operators. There is some fixed cost here, but the overall trend is that, and the other factor in here, of course, is capacity. One of the arguments against shared spectrum, shared infrastructure, is that, of course, you need the capacity. But in reality, this is we are modeling the capacity in the model we build. We're modeling the capacity as well as the coverage, and with these numbers of subscribers and the traffic consumption that we know goes with those subscribers, we know we can serve that with this number of devices. And then we go up another order of magnitude nearly, and we get to a tier 2 venue, a hospital. This is a US facility, 250,000 square feet over 4 floors. Not really a large, actually a smaller number of subscribers here, of course, because you're dealing mainly with visitors and medical staff who are not really generating the same degree of traffic as in these other places, other venues. And you can see there that the DAS and the single operator small cell then is much more price comparable. That even that the capex may be a little lower, the first year capex at least, and the rest is much lower. The OpEx associated with having multiple small cells in that venue, when you're talking about a much larger number, much larger square feet, you just need that many more small cells to cover that venue, and it becomes much more price comparable with DAS. But again, if you're able to share that infrastructure, again you get that huge reduction in capex and opex again, that brings the TCO right down. So,
Nick, I wonder if I could just ask you a quick question for clarification. This slide shows 325 subscribers, and I would think that for a major US medical facility, there's going to be more people physically in the building. So is this number related to the total number of concurrent active users, or is it just those people who are allowed to use the system, or the ones that have their phones switched on?
no, this is a peculiarity of the traffic model in this venue. I think that the actual number of people who are able to, who are wanting to use the system is surprisingly small, actually. And I don't know if Randall might want to comment on this, actually. That
for a facility like this, depending on the day, it certainly might be possible that if you have visitors in the building and things like that, but the concurrent staff, even though the overall staff of a medical facility like this, might be greater, there might be 3 shifts at any time. What that's meant to use is the maximum number of people who are in the building at a time that we would use to calculate what the traffic load might be on the network. So even though the overall staff might be larger, we would anticipate that for a facility this size, and this is not a very large hospital, that about 300, 350 people would be about the number of concurrent users.
Thanks very much. Back to you, Nick.
Okay, so thanks, David. So really that just sort of a whistle stop then through the range of buildings we modelled. I think we can see that in that middle prize, really from top to bottom, and even below the bottom, even in the smaller than the smallest middle prize, the economic benefits of sharing infrastructure are just manifest. They are large and obvious. So summing it all up, a very bullet-heavy slide here, but I think all of these things I think we touched on as we go by. So the economic viability of these in-building solutions has become critical. There's this huge unserved middle prize, which we have shown, I think, in terms of the model, but we're also showing in terms of our own deployments that this critical segment of the market is now being addressed, and we're happy that it should be so. Mobile carriers, we haven't talked about the struggles that mobile carriers have in order to, mobile operators that is, the struggles they have to expand their networks, and given that their revenues are generally falling. A way of managing the cost of expanding and densifying their networks is incredibly important, and this is really one of the most important ways in which they can manage those costs. And and this becomes ever more important as they move to planning 5G access. And of course, shared access, I think, shared spectrum, I think will become the norm in 5G as we move towards millimeter wave as well. I think the costs of managing that spectrum will become dominant, and a shared way of managing that will become the norm. I think we've seen the key market trends. I think we've seen that actually the unserved enterprise is going to become more served as operators identify this unserved market really adjacent to the one that they're very aggressively serving today, in the tier 1 end of the large enterprise. Technologies that enable them to do that are really available now and getting ready to be deployed, and we've shown all those cost advantages of doing that. Right. So I hope that sums it all up.
It does. Thank you very much, Nick. Just to move on from that section of the webinar, we've got one final question for our audience to answer. one of the key topics you've heard through the webinar is about which spectrum is most likely to be used. Will it be dedicated spectrum from each operator? Will there be some donor spectrum allocated by lead operator, or will it be one of these new systems like CBRS or multi-fire? And so it very much like your view on which spectrum is most likely of those four choices to be used for in-building. So please pick whichever you think, and so you should see the results on the screen. And as you can see, the winning candidate is the status quo, using separate frequencies by each operator, pretty much the DAS model, though there's 16% think the donor spectrum configuration is quite viable, and good support for both CBRS and multi-fire. So perhaps ask Randall, if you're online still, whether you have any comment on this result.
Yeah, I guess I look at this and I see quite a mixed bag, and I think that's in line with what we see. This is all very much an open question on how this will roll out going forward. So I guess I'm with the crowd on the uncertainty of the result.
Nick, any quick feedback from you?
I think Randall sums it up perfectly. I think it is, it's a very undecided question.
Probably the hottest topic is around this spectrum choice, and one viewer is calling it the elephant in the room very much. So, would we see that there are any examples of this donor spectrum from MNOs in any country around the world today, and are there any signs of this donor spectrum becoming available? And I'd maybe ask Nick for his comment on that.
Yes, there are actually. There are several examples of spectrum sharing in the world today. So the two kind of obvious ones, I think there's one in Canada where TELUS and Bell Mobility, I think, are sharing spectrum. And there's in the Nordic region as well, Telenor and one of the others, Telia, I think, I think they are also sharing spectrum. And so it's in that respect, it's more of a round robin type of donor. Each spectrum owner is donating spectrum in a venue, and they're sort of taking it turns to donate on a venue by venue basis. But there are a handful of examples around the world today, and I think the question about managing the economics of that, I think, are becoming clearer as people learn how to manage those networks. There's other examples where neutral hosts are taking the initiative in other parts of the world. In Latin America, for instance, we're seeing a lot of pickup, but no, there are examples, and we see them growing.
Okay, and kind of related to that is whether an MVNO, and we're thinking of one of these bigger companies that's maybe already got their own core network, whether they could bypass a mobile network operator and directly connect to one of these in-building systems. Is that a business model that could work?
Yes, definitely. I mean, I think the idea of shared spectrum, so CBRS, for instance, exactly allows it really takes away the distinction between an MVNO and a mobile operator. If you have spectrum available to you, then and as an MVNO you're already issuing your own SIMs to your subscribers, then you are indistinguishable from a mobile operator in everything but scale. And so that's definitely a way forward that's in play today.
David, the one part I'd add to that about the neutral spectrums, and this would apply to things like CBRS and multi-fire. It's not only what those solutions will look like, and they're very encouraging, but also when solutions will be available in handsets, and people are talking about later this year or early next year. But then as those handsets start to bleed into the marketplace, when will those capabilities be on the majority of handsets? And that's what we tend to look at. So all of these issues are quite complex to understand how they can pragmatically be implemented.
Okay. Another question on a slightly different topic. It's more to do with the financial modeling that you've done. What operating expenses have been factored into your cost model? Does this include the power, the backhaul connection, potentially even any rental, room rental space for the equipment?
Sure. So included, we've included when we look, specifically at the OpEx charges, we look at the cost for backhaul, the cost for ongoing maintenance, monitoring of the network. We look at access fees and rental charges, and also utilities are also part of the equation. We try to be as, and then also organizational support to continue to support the business. So try to be fairly comprehensive of the way we've modeled that.
All right, and probably our last question, given the time, more for Nick, as it's a technical issue, is how would operators equitably share the radio capacity of the small cell systems, and how would they ensure good quality of service for each of the respective operators?
That's a great question, and that is one of the essential roles of the neutral host, is to install enough capacity in a building, and then to allow it to be shared with the right quality of service. And forgive the product pitch, but this is exactly what the Viper solution does. Is it allows you to configure. You offer a controlled amount of capacity, and then you measure it exactly how much you delivered to each of the operators as you're delivering it. So the neutral host is there to make sure that there are enough cells deployed in the right places with enough transmission to carry the capacity, and the technology, the product itself, then allows you to configure the way that's shared between the operators. Exactly the issue we recognized at the outset, and the issue that we have solved in the solution.
Okay, I think we've just got time for one very last question, if we have some quick answers to it. Why not just use public Wi-Fi? That seems to be neutral host and accessible to everybody, and works with our handsets. Why not use that today?
It's a great question and a great point, and people do, of course. I mean, that is the default. People have deployed public Wi-Fi, and even when public Wi-Fi is deployed in good capacity, there is still this observed pent-up demand for cellular, and it's we're not saying that cellular is going to displace Wi-Fi in any way at all, but it seems that the paying customer really sees the value of cellular alongside the Wi-Fi, and that's just an observed fact. And who are we to argue?
Sure. And when we model these things, we always look at a combination of assuming that there is traffic that goes over Wi-Fi and traffic that goes over the cellular. That's different for different kinds of environments. For instance, even in a retail environment, when there's free Wi-Fi available, typically you still see that 70% of the traffic, just for example, still goes over cellular. People, and people always want to, still have that cellular connection. So both work in tandem. Sometimes in different ways, in different kind of venues, but our assumption is that both are hopefully readily available in the venues that we analyze.
Okay, thanks very much, and especially for the succinct answers there. So with that, thank you very much for your attention today. I hope you found it useful. I'd like to thank both our presenters for excellent content, and look forward to seeing you again on another Think Small Cell webinar.